everyone, it's Miss Julianne from the Wakanda Area Library, and I am here to talk about levers. More specifically, I'm here to talk about the catapults we're going to make and the airplane launcher, but they are types of levers, which means they're a type of a simple machine. And other types of levers you might know are wheelbarrows, nail clippers, scissors, tweezers. There's all sorts of types of levers out there. And what they do is they make our life easier because they help make stored energy become kinetic energy without us using more force. So those were some big words. So let me explain them for you. Stored or potential energy, as it's sometimes called, is basically energy before it's in motion, right? It's stored up, it's built up, it's ready to be used. So an example would be if you have a hammer, when you're holding the hammer, that is stored or potential energy. But once you bang the nail with your hammer, that's going to be potential or that's going to be kinetic energy. So that's going to be energy moving. So if you're holding a bow and arrow, when you have that string really tight in your hand and it hasn't moved yet and the bow hasn't moved yet, that's stored. That's stored and potential kind of energy. When you let go and it transfers that energy to the arrow and the arrow moves, that's kinetic energy. So that's energy in motion. So what catapults do and why they make our life so much easier is that they can magnify the force that we put on it. So back in the day, a long time ago, when there were castles and people would fight over the castles, people used catapults to launch giant things of rocks, right? Just giant rocks to hurt people or make sure people wouldn't come into their castle. Well, it would take several people to hold a rock, let alone try to hurl it so it would move somewhere far. So they came up with catapults. And what catapults would do is they would take the force or the energy that us as humans would have to put out, and all we would have to do is slightly move the catapult, and it would take its rock and fling it and move it. So we were no longer using the energy that it used to take to move a giant rock. And it was going much farther because it was able to take on more force. So if it took on more force for us that we wouldn't have to do, it would store more potential energy, and then that would become kinetic energy and the rock would be able to fly. So being able to magnify the force, or like I said, the amount of energy we are putting into something or we put onto something, is basically why catapults came into being. Now, all levers, and all catapults for that matter, because they're levers, will have something called a fulcrum. And a fulcrum is the part where it pivots. So when I say pivots, I mean moves. So if you have a pair of scissors, that would be like the screw in your pair of scissors. Or here, for example, I have a nail cutter. Where would the fulcrum be in the nail cutter? You're right, it would be right here. So with our catapults, where is our fulcrum with our catapults? Where is the pivot? This one became tricky, and I want you to think about it. I'm not going to give you the answer because I think you know it. And I think especially once you start experimenting it, trying to see how far you can get your pom-poms to go, I think that's going to be really great. And your pom-pom's going to go farther the more you have a force on it. So what in your catapult, or even when you're thinking about your airplane launcher, how can you create more force? And not necessarily from you yourself, but make your simple machine or your lever do it. So how are you going to make this have more force to create more potential energy, which then creates more kinetic energy? How are you going to do that? I want you guys to work it out. You know, does that mean moving your spoon? Does that mean moving this? Does that mean trying to stack this part higher? Does more height give it more force? How are you going to make it work? I have tons of faith in you guys, and that's all I have to say about levers and simple machines. And next I'm going to show you how to make your airplane launcher and your catapults, and then you get to go and have fun with them. I'll see you soon. Okay, so you should have a template or a piece of paper that shows you how to do a paper airplane, but I'm going to show you a simple style that I know. If you know other ways to do paper airplane, I think that would be awesome for your experiments. But this is what I found to be the simplest and easiest way to make a paper airplane, so I thought I would share. So the first thing I'm going to do is I'm going to fold it the long way. So I'm going to fold it like a hot dog. So you want to make sure you try to match your edges as best as possible, and then fold down that crease so you'll be able to see it. And then you're gonna undo that. And then the next step you wanna do is you wanna kind of make your paper look like a house. So you're gonna fold in the top corner to make a triangle on the top, and you want the sides to meet that center edge. And same over here, you want your sides to meet that center edge. And so now you should have a shape that looks like a house, right? You've got two triangles and a square on the bottom. And then each side you want to do half one more time. So you're going to fold it in half so it looks like this. And you want to do the same on this side. And you want your edges to meet up as much as possible. If you see here, my edges don't quite meet up, but it will be okay. And then the next thing you do is you're gonna fold it. So now you're gonna have something that looks like a really elongated, long triangle. And then you're gonna fold over the wings half. So, like that. And then flip that over and fold. Now you can fold them to any depth or length. I just think about half seems to work best. And then you'll have a paper airplane. Once you've made your paper airplane, you're gonna want something to anchor your airplane in the launcher. So what we're gonna use and what you get is a paper clip. And this paper clip is going to be what anchors it into the rubber band of the launcher. So what you're gonna wanna do is take your paper clip and then bend it so it has something that will catch on the rubber band. So it's gonna look something like this, because you know you wanna be able to catch it on the rubber band. So once you do this, you're gonna stick it in the front of your airplane so it looks something like this. Once you have your paper clip inside your airplane, you're going to want to tape or staple it so it stays in your airplane after it's launched. So I'm going to go ahead and tape it, but like I said, you can staple it, you can use tape. There's a couple different ways. So you'll see now that my paper clip is pretty secure. I think I'm seeing it move a little bit more than I would like it to. So I'm just going to go again and tape it again. So now it's pretty good. It's moving a little bit, but not a lot. And that's what you want to see. So now that I've secured it, the next thing I'm going to do is I'm going to wrap my rubber band around my pencil. So you want to wrap it a couple times, maybe even crisscross it to make sure it will stay. And then when you're preparing to launch your airplane, what you're going to do is like I said earlier, you're going to anchor your airplane with the paper clip inside the pencil with the rubber band. You'll pull back to create that potential energy, and then you'll let go. So pull back and then you let go. And I'll show you that outside because I don't want to hurt anything in my house. Okay, so I left you with our airplane and its paperclip anchor, and then we have our version of a catapult, right? Our airplane launcher. And this is going to help us create our stored or potential energy and turn it into kinetic energy. So I have one rubber band and it's around the top of my pencil. And what I'm going to do is I'm going to put my paper clip inside so it catches the rubber band. And right now when I pull it, that's going to be considered potential or stored energy. And then once it starts moving, that's kinetic. So I have it like this. And I told you I'd do this outside because I didn't want to hit anyone in my house, including my cat or any objects. So we're gonna go, and then it launches. And that is how you do your paper airplane launch. Okay, so the supplies you should have been given for your catapult are, you should have 1, 2, 3, 4, 5, 6, 7 craft sticks. You'll have more than 2 of these. You'll get various sizes to help you test, but you should have a couple pom-poms. You should have 1 spoon and 4 rubber bands. And the first thing you're gonna do, and you'll see that I've already decorated my craft sticks. You can do that if you want your catapult to look different. The first thing I'm gonna do is stack up 5 of my 7 craft sticks. So 2, 3, 4, 5. Once I have 5 craft sticks, the next thing I'm gonna do is I am going to tie a rubber band around each end. And you're gonna have to go probably a couple times. I gave you guys big rubber bands. You wanna make sure it's nice and tight. Take your other rubber band. So then it should look something like this. Then you're gonna take the 2 that are left and you wanna make it like, almost like you're stacking them right, but you're only gonna tie one end. So I'll tie my bottom end down here. And then what that will do is it'll make it like a mouth or a beak, right? Where you can move this end, but you can't move the other end. So it should make a V. And then once you've done that, you're gonna make the V. So make this and slip this in between. So then it's gonna look like this. And you can experiment too with how far it works for your spoon. Like, will your spoon launch the pom-poms better if it's like this? Will it launch it better like this? That's part of the experiment, is you can see what makes a better catapult. What do you guys think? Because this ledge, right, the lever component gets taller the further I move it this way. So I'm gonna keep it this way because my hypothesis, or my guess, is that having it taller is gonna create more force for my pom-poms to move. So then you're like, well, what's left? Your spoon. So the first thing you're gonna do is you're gonna slip your spoon underneath that rubber band. But that's not gonna really be enough to totally keep it in place. You'll see it's kind of wibbly wobbly still. So what you're gonna wanna do after that is take your last rubber band and then you're gonna tie it around the top portion of your spoon. So kind of like, just enough to keep it steady. And as you can see, this is wibbly wobbly. So you're gonna wanna make sure you use 2 hands when you're setting it up. And I like to, when I launch, keep my fingers down on the bottom of the 2. So you'll see where the position of my fingers are. And then, while I'm setting everything up, and then I'll put a pom-pom in here. And what do you think I've gotta do? Do you think I just go like this? I mean, how does the lever work? And can you guys remember what a fulcrum is? Where would my fulcrum be? So I want you to think about those questions while you're making your catapult. And as I pull my catapult down, it will launch. And that is how you make your catapult. So I want to thank you for joining me today. I hope you have lots of fun building your catapult, testing how far your pom-poms will go, making your paper airplanes, testing how far you can launch them. I just want to remind you to be careful, and if possible, do these activities outside or wherever your grown-up agrees for them to be. I don't want to hear that you hurt anything in your house or potentially like hit your sibling in the head with an airplane or anything like that. I want you to follow your grown-ups rules and get your grown-ups permission before doing these activities. I also want to make sure that you guys know that our summer reading club is about to end. So if you are participating in it, please get your minutes in so you can get your prize. And I just want to remind you guys that the library is open and we'd love to see you. So thank you for participating in July's Summer STEM Club, and I will see you soon. Bye!